focus F3 16-inch, and then I would do a Cassegrain mirror because I didn't know what I was talking about. Then around 2015 or so, I remember being here and hearing Mel talk about very thin glass that had been slumped to a curve and ground and polished. And I was like, I have that blank. In fact, it's already polished, but it looks like dog do. And well, with a little bit of mentoring and then a lot more mentoring, I ended up turning that blank into something and then breaking it, and then breaking another blank, and this is the third blank, which is now successful. So broken glass, which I've labeled, you can see on the secondary here, is a 16-inch telescope that weighs 28 pounds, fully assembled without finders or eyepieces. And I'm not going to lift it above my head, but that is an OSP condition. So there's 16 inches right there. And it has no wood. It is made out of aluminum and plastic. Some of that plastic's 3D printed, some of it's not. Some little bits are steel instead of aluminum, but there's no wood. And it doesn't bother me if it gets rained on. Except that the primary mirror is actually silver. It's front surface silver. Now you might think, well, that tarnishes, and it sure does, but there are some tarnish delaying coatings that we put on, Midas tarnish shield. And that has enabled mirrors to go as long as 3 years, maybe a bit more, without tarnishing, if you keep them dry. Keep them dry and keep them clean. Dust gets onto silver, and then moisture in the air gets in the dust, and stuff leaches out of the dust and starts corroding your mirror, which is sad. But it's so easy to recoat. You get a dirty mirror, and it's like, well, I'm not going to clean it, I'm just going to recoat it. So I did this just last week in anticipation of the Oregon Star Party, and I got to say, it is the best silver coating I've ever done. I will be presenting a live demo of silver coating at the First Light Telescope Conference. That is a conference in October. It'll be at Dan Gray's Technical Marine Services on Swan Island. Well, many of you are familiar with that place. Well, we're having a 3-day international conference. It's been, how many years running now? Howard?
Yeah, at least 20.
Well, at least 20, yeah. And it's quite the thing. People come with some very creative telescope ideas and astronomy ideas. And if you have an idea that you'd like to present, talk to me. I am taking entries for presentations all summer long. Okay, a few more things about this. You'll see that it's a string and strut truss system. It's called tensegrity. Don Peckham, another one of our gang, who's not here this week, unfortunately. Don Peckham came up with the application of tensegrity to telescopes, and he demonstrated it here on the Walkabout back in 2015, 16, something like that. And I was like, no way. And then I come back the next year, and it's like even better, and I'm like, oh yeah way. So I was able to make a scope that is so incredibly light thanks to the tensegrity idea and the very thin meniscus mirrors. What else do I want to mention on this that's super important? Oh, is Ed here? There you are. Looking right at you. It's like glasses in the hat. Well, I have on here the fluid motion control devices, and I want you to check them out, man. So Ed pioneered that on Elvira, the idea of using these fluid motion control devices to allow your scope to move very smoothly, which when you only weigh 28 pounds and your surface area is so big, it really was, it would have been a failure without the motion control devices. I did it all in Teflon first, and it was just jumpy. You know, it was like, I'm trying to track the high power planet. It's jump, not working. So the fluid motion control came in and saved my life, made the telescope actually a joy to use. Another thing I want to point out is I have these top collimation bolts here so I can actually sit. By the way, yes, this is a 16-inch scope that you sit and look through. And I use the laser collimator, but then I can put my eye on the eyepiece and I go tweak, nudge, tweak, and bam, collimation is always good. Even if I move it down, and now the collimation isn't good anymore. It's just, oh, well, I can fix that faster than I can even think about, oh, is my image out of collimation or not? I just make it right. So,
focal length of your mirror?
Focal length of the mirror is 1,160 millimeters, f2.8. Very fast. It's f3-ish with the P2 coma corrector in it, and it needs that for nice wide field views. The true field with this 100-degree Nikon 17mm eyepiece, the true field is over 1.5 degrees. I'm forgetting the exact number now. Yes.
Could you tell us a little bit about the secondary support?
The secondary support is. Can I tell us about the secondary support? Yes. The secondary support is honestly very janky, and I wish it were in better shape. I had initially done it in as a wire spider. Could not hold collimation. I don't know what I was doing wrong. This is not my first wire spider either. So I finally punted and I used galvanized steel and I put in some aluminum angle blocks and 3D printed a secondary mount to kind of hold it to. And it's hanging on and it's ugly and it's going to get shaped.
But it's also tensegrity in some senses, right? Is it tensegrity? Essentially, you tighten it and it pulls in tension.
The secondary?
Sorry, pardon me if I'm. Yeah.
Well, no, not really. I mean, it's sheet metal.
Okay.
There's some tension on it.
Okay, it's held by tension sheet metal. Okay.
Yeah,
Got it.
it's
Got
not
it.
really tense. No. One more thing I want to show you. The binoculars here are not mine, so I'm not going to talk about them, but they come with these really cool filters that you have magnets on them. And I can just come over here and put a filter in on the same magnetic mount, and there we go. I've got my filter. I don't have to do threading in the dark. I used to have on here a little filter flipper. It was just a single, filter wheel kind of a thing. And then I got the binoculars, and now I've got 5 filters to choose from. And so I wanted to not have a filter wheel, but a quick change, and that enabled me to do that. So. All sorts of cool ideas came into this thing. I'm very happy with it. My goal was to make a telescope that I could carry with me into my 90s if I stay healthy. So I'll keep pumping 3D print, I guess. I don't know. All right, so I've been given actually 3 telescopes to talk about. This is broken glass 16, and then I got a couple of solar things to show you. And I'll take one more question here, and then we're going to move just over to my scopes over there. Way in the back.
What is 3D printed?
What is 3D printed? The focuser is a helical focuser. I used to have on here a 3D printed Crayford, but that thing would not stay under tension. It just, plastic would creep. So I said, screw it. I went to a helical. It has 5 millimeters of travel per turn, so it works quite well with a super fast scope like this. I just grab the eyepiece and there we go. Just grab the eyepiece and focus. No, not PLU. It is ETG. Yeah. I also have 3D print showing up in various places throughout the scope, and some of it was a good idea, and some of it wasn't so good. There is a rib that runs around the altitude bearings, and that's ostensibly to give them some stiffness. But the stiffness of 3D printing just isn't as good as the stiffness of using this Alumicore stuff. This is plastic with aluminum facing on it, about a half a millimeter thick aluminum facing on each side, and you glue it together with epoxy and do it like an I-beam, and it's the stiffest stuff in the world. It's got a stiffness to weight ratio that just blows away plywood. It just blows it away. You could not make a 28-pound, 16-inch telescope out of plywood. It would not work very well, I'm convinced. Plywood would be too thin. Dan, and then we're going to move. Yes?
When are you going to make a 3D printed mirror?
When am I going to make a 3D printed mirror? Dan, my rates are very steep, but I'm sure you can afford it. So we'll talk. I won't guarantee the performance, but it'll be yours. Okay, let's move over here. Okay. Yeah, I can do it. Thank you.
You learn the hard way.
Okay. So, Dave Kaznick asked me to talk about these two instruments. I'll start with the C8 mounted in the Dobsonian on a tracking platform. And this is not its first time at the OSP, but I see we have a lot of new people, so why not? This is the result of me being very frustrated with solar filters and poor results from eyepiece projection. So I got the idea one day around 2009, 2008 to project into a black container, and I used a 5-gallon Home Depot bucket, and thus was born the Sun Bucket. And it was very rickety. I had the C8 on an equatorial mount, German equatorial, and the bucket hanging off the focuser, and it was just icky. So a couple of iterations later, I have Sun Bucket 3, and it is nothing more than a C8, a nice plywood box to project into. The whole inside is painted black. There's a piece of metal on the bottom that's painted white, and then there's a front surface mirror at an angle right here, and you look into it like this, and you see a sun projected down on the bottom, and it's correct image. It's right angle correct image, basically. There's 4 bounces. There's 1, 2, 3, and 4 off of this mirror, so it comes out right. And then that matches the right angle correct image I have on my H alpha scope. So I can go H alpha to white light and know, oh, those sunspots match those things I see in the H alpha. As far as safety is concerned,
Can
people
you show us again emphasize where you look through it?
well, yeah, you look through it like this. So I'll just kind of move around, but yeah, you look through it like that. And so the image is down here on the bottom, and you just see it off the mirror. As far as safety is concerned, it is an 8-inch telescope collecting a lot of light, but that light comes out through an exit pupil outside the eyepiece down here, and the only way you're going to get hurt on it is if you go, ooh, I wonder if it's hot there. And then you will know the answer. Otherwise, the beam cannot touch the wood. It gets vignetted in the eyepiece, which is all metal, so I made sure to get an all metal Plossil, just a junky eyepiece. And then the beam expands out to about 8 inches on the back, so the light density on the paint is no more than just direct sunlight. So it's totally safe for viewing, and it's somewhat safe from itself. Long ago, I did manage to melt just a little bit on the baffle on the secondary. I'm not quite sure what happened there still, but yeah, okay. Question right here.
Are you sharing views through your solar telescope today?
Well, I was sharing all day, and now it's down in smoke, and people are casting shadows on it. And
Tomorrow.
Yeah, tomorrow you'll be able to look at it. Same with this device. This here.
Maybe
yeah.
people could step back just a little bit. So
Well,
you
no,
can see it.
well, don't even bother. I'll just hold it up.
Oh.
Yeah. I can't really demo this like I would have wanted to at noon. But this little device here is a spectroscope, and now I go into my sales pitch mode. I make these and sell them. If you're interested, you can talk to me. The spectroscope goes into the focuser of an ordinary telescope, and you can see spectra of stars with absorption lines in them.
That's cool.
Yeah, it's very cool. It's called the Spectre. It's available from QuinsightSpectre.com. So is the QuinSight, which I skipped over just to save you from more advertising. But what I wanted to show you is that this also works in the daytime. And the kind of novel thing here is that I got this piece of chrome pipe, and I mounted it at 45 degrees, and if I polar align the pipe, so I just put it on level ground, point it north, then I get a reflection of the sun in that chrome that just stays put all day long, because the sun just rises and goes around the axis of that cylinder, and the reflection just parks itself right there. So I can set this up, and I do this at outreach all the time. I'll just set it up, point it, there's the spectrum, and then I can talk about this, and people can go look, and it's still there, and I don't have to pay any attention to it. So, yeah. Anyway, that's that. I wish I could show you some beautiful spectra right now, but everybody's casting shade on my chrome. Okay.
So I was walking by, and first of all, I see this hybrid scope, and I think, what is that? So,
Yeah.
but this was really super intriguing, and it is so cool how the sun glints off this tube. So this nice little sliver of light goes in there, and you could see the absorption bands. It was really fascinating. I mean, I wanted to go
You
get some.
put this into a telescope, and every single visible star in the sky does the same thing, but they all look a little different, right? In fact, there's 7 main categories of stellar spectra. I can easily put visible stars into 3 of those categories, kind of like OBA, FG, and then KLM, sort of like that, and I could say, oh yeah, it's one of those categories, and then I have to look up the subcategories, but yeah.
Could you tell people a little bit about absorption lines?
Yeah, so you want to go into quantum physics, we can just go there. Sure, why not? So absorption lines, I won't do the quantum thing. They are the chemical fingerprints of the elements in the solar atmosphere, or in any star's atmosphere. What happens to gas in a vacuum is it will either fluoresce or it will absorb, but at very specific wavelengths. It's what gives the sun a beautiful view in hydrogen alpha light, right? If you have a hydrogen alpha telescope. It's what causes nebulae to glow green or red. In the case of the solar atmosphere, now we're looking at a very bright disk, and those electrons are doing their little quantum thing and hopping up to higher energy levels, absorbing light at a particular frequency or a particular wavelength, which shows up as a dark line in the spectrum. You can see countless lines in the solar spectrum, and I literally mean countless, because astronomers still haven't figured out all of the absorption lines in the solar spectrum if you go in from the infrared into the UV. They're still working out some of these things. We don't know what chemical compounds they might be yet. I think that is fascinating when we're talking about, the vastness of space, and our nearest star we still haven't totally figured out. Yeah?
Do you get a spectra from any nebula?
Yes, absolutely, spectra from nebulae. And I invite you to come over and look at one tonight. I will show you. There's a notable discovery nebula, the Cat's Eye. And Howard and Akarsh have a story to tell about that. But it was the first object looked at by William Huggins in 1870-something in his spectroscope on his 8-inch refractor. And him and a chemist looked at that, and they immediately knew the nature of these things. Where the debate was, are they unresolved clusters, or are they clouds of gas or something else? Once they saw that, they were like, oh, well, of course. And that kind of changed the course of astronomy and physics and practically every other science since. So I think it's quite awesome to repeat that and see what they saw.
Hey Rob, I have a question.
Yes, question. Oh, wait, no, Dan.
No, this is not a joke.
Okay.
Have you looked at the moon, like with your solar scope here? I mean, take the filter off and see the moon.
Well, there is no filter, Dan. So if I look at the moon, I haven't actually thought to do it, but why not? When it's nice and dark and there's the moon, I could probably see it okay on that screen, but it would be far better in the eyepiece, because it's going to be very faint.
Well, one more question.
Yeah.
What about the Horsehead Nebula?
That was the joke.
Okay, serious questions, and then move on. All right, thank you very much. Let's go to the next scope. Oh, wait.
If we come by tonight, will we see absorption lines from the smoke?
Absorption lines from smoke. Unfortunately, there would be some in the infrared, I'm sure of it, but not in the visible. Yeah.
All right.
Okay.
One more question?
Anybody? Yeah, I'll be right there mostly. Yeah, this is going to go over there, and that won't be being used. But tomorrow, come by and look at the sun, spectrally and white light, and then find an H alpha. They're all over the place.
Nice.
Yeah.
All right.
Okay.
Okay. Thanks, Rob. That was great.
Thank you.